As you start through, you have to start by identifying your x-intercepts, identifying your vertical asymptotes, and then identifying the horizontal stuff. Remember, your x-intercepts are located at the zeros of the numerator, which means I have to set the numerator equal to 0. I get x squared is 3/2, which is x is going to equal plus or minus the square root of 3/2. Now, in the grand scheme of things, we would normally rationalize that, correct?
Yeah.
But if I'm looking for an x-intercept, do I need to know exactly what the radical looks like? Do I just need a decimal equivalent? When you're doing these types of problems, it is okay to leave your x-intercept or a vertical asymptote in an unrationalized form. Bless you. Okay, so you do not have to multiply top and bottom by the square root of 2 and get root 6 over 2. It's okay to leave it like that because when you go to graph this, we start identifying these things. What's the decimal equivalent of the square root of 3 over 2? 1 point. Square root of 3 over 2.
1.2.
So it's about 1.2-ish, and then there'll be negative 1.2-ish. That's what we're looking at being able to do. You told me that the x-intercept is located at the square root of plus or minus square root of 3/2. That's fine. Go to your y-intercept, or excuse me, vertical asymptote. Vertical asymptote's located at the 0 of your denominator. Take your denominator, set it equal to 0, and solve for x. You get? There's your vertical asymptote. Horizontal asymptote. These things will have at most one horizontal asymptote. This is where I think some of us were asking questions yesterday. When you look at some of these graphs on your calculator, did you guys notice how some of them looks as if they are passing through a horizontal asymptote? Okay. What happens is that there is a little bit of a caveat, I believe you call it, a little disclaimer. It's so that when you have these horizontal asymptotes, yes, you're identifying where it could be, but sometimes it's not really there, especially for certain parts of graphs. That's why they say at most. I still want you guys to say where it would be located and plot it, but remember, sometimes your graph will still go through it, because at most, it could have one. It's just a little weirdly worded version of it. Does that make sense? One of the reasons you see this is when we talk about some later on today, we're going to have a perfect cube root in our denominator, which means when we factor that out, we're going to have one solution and a couple of imaginary stuff, where it's going to be difficult to be able to plot. Whoa! So that's where they get these at most things. In this case, my numerator's degree is higher than my denominator's degree. Therefore, m is greater than n, so I have no horizontal asymptote. Now, from this point, all I would have to do then is go to my calculator and get ordered pairs on both sides of the asymptote. If you did that, you will have only probably have seen one side of this curve. I believe you see one side of the curve and it's kind of doing this. Am I right? Because the window on your calculator is not showing the other half that's down here. Okay? When you get to the point of graphing, and you're looking at your table, this example we have, what was it, 2x squared? Hold on, I can't type that fast. Jeez Louise. 2x squared minus 3.
Plus. Divided by x.
I hate this stupid thing. It is so slow. All right. In a standard 10 by 10 window, you're not going to see that lower portion of the graph. But if you go to your table, you'll see that at -3, it's at -15. At -4, it's at -29/2. So when you start to list out your ordered pairs, what we're going to do today is you're going to take your table. We had no horizontal, so we say none. And we're just going to write down ordered pairs. -3 and -15, -4, and 29/2. You could write 14.5 if you want. And then the other one would be at -1, -1, and 0, -3/2. That's what you're looking at being able to do. Because from there, it's a matter of anybody can graph these with a calculator and just look at the picture and redraw the picture. I can give a calculator to anybody and say, hey, graph this, and they'll be able to go to the y equals button and just type it in and get a rough sketch. What I want you guys to be able to do is identify all the important bits and pieces of that. That's why I was saying, what's your x-intercept, what's your vertical asymptote, horizontal asymptote, things like that. Okay?
Yeah.
Let's look at the next one. No, we're just doing the setups. Like I'm showing you today, we're going to start looking at how we would continue to graph because that's what we're going to be doing tonight. Do we have an x-intercept here? Nope. Vertical asymptote? No. Good. There's no vertical asymptote. Why? It's a non-real number. Very good. The 0 is a non-real number. And then your horizontal asymptote. My excuse me. My denominator has a higher degree, so it's going to be at 0. Again, when we get to this part, it's a matter of using the table function in your calculator to get ordered pairs. Horizontal asymptote at 0. One. And here's some ordered pairs. -4, -1, and so on. Okay? And I'm assuming that at this point in time, you guys will be able to read tables and plot points. All right? Excuse me. All right.
Are you doing anything more to your door?
No, we're all out of lights.
So,
There's not much left we can do.
a lot of electricity running through there.
Good chance, yes. But I never blew a circuit, so that's good.
Yes.
Yeah.
I did not bring a fireplace. I was going to bring a fireplace, but then I'm like, yeah, that's too much.
How could you bring a fireplace?
You've never seen those portable fireplaces?
Like the electric.
Electric, fake stove looking ones?
I do this sometimes.
That it has the...
Why did you do that? That would have been funny.
Yeah. It's a little too much.
No, not at all. Not at
That
all.
would have been so good. It could have just sat right
I know, I just thought it would have been too much.
No.
Yeah, but like,
supposed to
oh,
go
hey,
side- you're supposed to go
judges.
too
Hey,
far.
judges. I know my door is a little mangled, but here, sit by the fireplace.
Yeah.
And then,
We may or may not be bribing them also.
You're gonna bribe them more than what's a pizza costs.
Again, what are my x-intercepts on this one? Plus or minus 2, very good.
Do you have money to bribe them?
My vertical asymptotes, do we have vertical asymptotes here? Nope.
No.
And horizontal asymptotes are? Degrees are the same, do we agree?
Yeah. So this is
No. These are coefficients at 1 over 1.
sweet. So how did?
then I'm assuming you guys can use the table again.
There's a lot of graphs.
Yes, it can get pretty nasty. The stuff you're gonna look at today gets pretty ugly.
Why are you showing?
Yes, sir.
Are you gonna make us graph it in the quiz?
Yeah.
No, it's not that hard.
For example, let's say that this question's on the quiz. What would I expect you to be able to do? Well, I would expect you to, first of all, find your x-intercept. -1 for it. My vertical asymptotes, plus or minus 1. Horizontal asymptote,
Zero.
Zero.
Now, when I start to look at this on the graph then, at this point is when you'll be able to use the graph. You've listed out all the important stuff, which means we have the vertical asymptotes at plus or minus 1. We have a horizontal asymptote at 0. Okay? This is one of those problems that splits it among basically 6 different spots within the graph. Do you agree?
Yeah.
Now, I want to be able to get 2 points to the left of an asymptote, all the way over on this side. I want 2 points in between, and 2 points on the end. So what we're doing here is we're going to use our table function to list out some ordered pairs. What do we got? Was it 4x? I'll show you how that would look. Four x plus 1 over, what was the denominator again? X squared minus 1?
I think.
Do you see how there are 3 parts of this graph?
That's wacky.
Like, there are one part of
Here's what you want. If you look over here, to the left is one spot. In between is another. And to the right is the other. You want to get ordered pairs in between all of them. Your table will allow you to do that. The only thing that's going to be a little weird is that in here you'll have to use a different table set. Because if you have 0, I believe in this one. When I'm at 0, I'm at -1. Excuse me. So I know that this one is here. Do you know how to change your table set to get a different value? What do? You're shaking your head?
On the table?
Yeah.
I gotta go.
In order for me to, right now it's only giving me integer values. I want to figure out what it is at maybe at 1/2. Go to your table set, yeah. Hit second window and go to your table set and then change it to 0.5 real quick. And go back to your table and look at what it is at 0.5. Everybody see that? Yes, ma'am.
How much of the test is that?
None of it. Yeah.
Which
Because you still have to be able to do all the other stuff. The calculator won't allow you to find all that other stuff until you get to the ordered pairs, you know what I mean? It's the only thing it's going to let you do. Yes, sir?
Isn't there a way, like, on the table to type in?
You can. If you change it
Like
to,
that plus.
you change it to ask, the independent.
All you gotta do is hit the plus sign.
Oh, yeah, you don't have to go to the window, you just hit.
I didn't know that. That's cool.
Just
Sweet.
Plus sign, bro.
Learn something new every day.
You're welcome. You can tell.
I'll tell everybody. I'll tell the world.
Oh, I
So I hit plus and I can change it to 0.5. Well, that's pretty awesome.
Merry Christmas.
Merry Christmas to all. And to all a good night.
Sweet, now
Hey, just in rugby, it says it at the bottom of the screen.
I didn't know it did that. I had no idea. I didn't know that's what it did. I had no idea.
Press plus for triangle table.
But he was like,
Who reads instructions? Come on now.
actually, studies show that.
Is that what you're
Again, from that point on, can we go ahead and use the rest of the table to get other values?
Yes.
Thank you. I didn't realize it did that. Okay, absolutely.
You're welcome. Extra credit?
No. Hey, does somebody know whose Tupperware that is? There's many Tupperwares.
I'll take it. That looks
I don't remember.
Tumbleware?
Tableware. Wait, how do you get back to one then?
What are you wearing?
In 30, you have to do a little bit more work. Your x-intercepts, guys, you're going to have to factor. By setting that equal to 0, then you'll have to factor. So what times what's 2 you add together to get 3?
Oh, 2.
Factor it by grouping.
It's like,
You're impressive.
it sounds like someone's sword fighting. I would.
You still got to bring your bow and arrow, but
I will.
gonna go and arrow face off.
I will.
No, you gotta-
So your x-intercepts are at -1/2 and -1. Your vertical asymptotes are going to be at the denominator zeros. Well, that's x minus 4, x minus 1. So it's at x equals 4 and -1. Horizontal asymptotes. Does this have any horizontal asymptotes?
Yeah.
Where?
Two.
Very good. Since the degrees are the same, you take the leading term coefficients and you have 2 over 1. So we might have a horizontal asymptote at y equals 2. We start put some stuff on paper. -1/2, -1. Vertical asymptotes.
I go to
This is all messy.
Yeah, I know. I saw this.
I wrote it as it's supposed to be positive one here. I'm sorry. Positive one. I put it on the. I accidentally wrote -1 for a vertical asymptote instead of being positive one. That was my fault. And then at most there might be that other asymptote at 2. Oops, wrong way. Gentlemen, come on. And then again, it's a matter of using the table function. Since this has been broken off into 6 possible spots, you're going to wind up with having 6 ordered pairs. Okay. You'll wind up with 6 ordered pairs. Okay? Yes, sir.
So on the quiz, somebody wants to list the word pairs or?
Yeah, what I have done on the quiz is I've made it kind of dummy proof so that it doesn't allow you to forget a part. So if there is a certain amount of ordered pairs, there's a certain amount of parentheses.
Oh, okay.
Does that make sense?
Yeah.
Oh, there's
With the like graphs to be on the bottom.
I don't know, look at your graph.
I'll see if there's a-
Look at your graph and then you use it, because after this point, I mean, in all honesty, it's just pressing buttons. And what does that tell me that you know how to do? Read?
I'm like in last this like y equals 1 over x squared minus 1, I think.
Yeah.
At the side just to like +2. What does that change?
Oh, after everything?
Yeah.
It moves everything up 2 spots. It would move everything up 2.
Wait, it doesn't matter which one you play.
And then lastly, My x-intercept is to be located where? 0. Vertical asymptote, -2. Horizontal asymptote, m is greater than n, none. Again, as you go to this, it's putting the critical information in. Table values. When there's just one asymptote here, how many ordered pairs do you think you need to have? 4. We have 2 on each side. Okay. It's when things start getting weird with the other ones is when you have to worry about it. The only other stuff really that you guys have to pay, the quiz itself is extremely straightforward. There's really nothing here that's going to throw you for a loop. Didn't mean that. You have to remember that there was also the other stuff that we did on Monday where we were working with that A, H, and K style, where you still had a 0 because it was the denominator for your vertical asymptote. You also had that horizontal asymptote for the K value that was tacked on at the end. Now, the only other messy part was when you had the AX plus B over CX plus D, where you still have zeros of the denominator for vertical asymptotes, and your horizontal asymptotes were your A over B. So there's just a couple of bits and pieces to be able to remember. You have to be able to show the important parts of these graphs prior to using the calculator. Like I said, the calculator is fine and dandy, but it doesn't tell you where everything is located. You have to be able to write that stuff down. Okay? That's very, very, very straightforward. Now, with that being said, what I want to give you guys is another 6 of these just to continue with the graphing. And I do want to show you what to do when you have the weirder values, because some of these are going to get to be a little bit larger stuff. It's the same page. It's just the next 6. I got more graph paper, just what you always wanted. And I want to explain to you guys what are you doing when you're finding all these weird zeros. Yeah.
551.
Now, if I'm looking at 32 to start with, if I'm looking at number 32 to start with, and I'm going to identify my x-intercepts first of all, I have to set my numerator equal to 0. I have a cube term here, so I have to check to see if I have a perfect cube. Is 3 a perfect cube?
Yeah.
No. Your perfect cubes are 1, 8, 27. 3 is neither of them, or any of them.
Neither or
Well,
a cube comes from 3.
So that means in order to figure out where your zeros are located, you have to solve for x. So you get 3x cubed is -1. X cubed is -1/3. X will be the cube root of -1/3. Can I take a cube root of a negative number? Yes, I can. Why can't I? Because it's an odd exponent. Since it's an odd exponent, I'm okay to take these nth roots with the odd number values of negatives. It's okay. So when I go to figure out where my x-intercept is, it's the cube root of -1/3. Again, that's not something I'm going to graph. I don't know where that value is, but could I figure out what the decimal equivalent is? How do you do that? You type it in your calculator. So if you type in your calculator the cube root of -1/3, I believe you get roughly -0.7 after you round it all off. Okay. So at this case, then, there's your x-intercept. On your graph, that's what you would start with. My x-intercept is located about here. What's that?
Oh, no, so you take it.
Yes. Yeah, I'm going to go through it. It'll do the value for you. You don't have to do plus or minus because it's an odd number. It's an odd nth root. It's just that is the value. When I do my vertical asymptotes, it was 4x cubed minus 32 equal to 0. Now, what's your first rule of factoring? If I factor out of 4, I get x cubed minus 8, right? You agree?
Yeah.
If I divide both sides by 4, it goes away, right?
Yeah.
Okay. So now I have x cubed minus 8 is 0. Obviously, if we went to go ahead and factor all that out, you'd get some nasty long setup. You'd have x minus 8, x squared plus, was it 8x minus 64, I believe? And this is going to give you imaginary solutions. Yeah?
Okay, is one easier though to move the 32 divided by 4 than if you were to factor it out?
I'm showing both ways here. Yeah. Because here,
How to do that.
you're still getting the same value. In this case here, if I set this up, I'm still going to get a 0 at 8. Here, when I go over, that's supposed to be q, excuse me, this is supposed to be a 2. I wrote that wrong. Sorry about that.
You left it.
So it's supposed to be x minus 2, then x squared plus 2x minus 4. So I still get 2 as my 0. You could just take a picture of somebody's book or look at it online. Yo,
Is there an online book or just that website?
there's no online
Because
book.
on your website you had like PDFs. That's what I used.
There's no online book for this because this book is so old. I don't think they had the internet. Okay. It's there are specific links that I'm allowed to use. I had to get things clear. All right, so now I have a vertical asymptote then at 2. Okay, I solve my denominator for 0. Vertical asymptote at x equals 2. So as I'm going into this, I know now I've got the asymptote at 2. 0 at cube root of negative 1/3. And then the last bit was my m's and n's. They're equal, so where's your horizontal asymptote? 3/4. So when I put that through, it's kind of like that. Now, remember, it's at most, it might be occurring. When you go to your graphing calculator and you substitute all those values in, it may or may not be crossing over that value. If it's crossing over that value, that's okay, because it's at most occurring. It may or may not be there. Okay? So when you look at your graphing calculator, was it 4x?
3x cubed.
X cubed plus 1?
Yeah.
What's the denominator again? 4x cubed.
Minus 32.
So when you look at the graph, that horizontal asymptote will be there. Can you everybody kind of visualize that it's not passing through? It's kind of bounding around there. Again, go to your table function then. I need 4 points to the left, 4 points to the, or excuse me, 2 points to the left, 2 points to the left of your vertical asymptote. Change this back to 1. At least I know my asymptote's from a hole in the ground. Who's that?
I don't get it.
Who's that? I'm Mr. Piscoda.
Oh, that's good.
Again, from here, I'm going to assume that you guys can type points. Okay? That's the kind of stuff I expect you to be able to do. I don't think any of you guys are gone tomorrow because of the orchestra thing, right? That's me. You guys stick after school then and take the quiz. All right.
There's 193 over 224.
What?
That's what it is.
Okay. What's the decimal? Budget. Hand it over.
Yeah, that's what.
All right.
4. But like,
Yep. Work on those now. We'll give you a little bit of time. I'll collect this stuff tomorrow.